Welcome to Capacitance and Energy of Sphere. We have seen some important points about spherical shell. This is a charged spherical shell of radius capital R. Charge is Q. P is a point, distance. P is an outside point, distance small r from the center of the shell. Then electric potential at P, V outside, equals 1 by 4 pi epsilon 0 into Q by small r. On the surface of the shell, V surface equals 1 by 4 pi epsilon 0 into Q by capital R. Capital R is the radius of the shell. V inside is same as that on the surface, that is V 1 by 4 pi epsilon 0 into Q by capital R. In the case of conducting body, if the material is conducting, these results apply equally to a solid sphere also. A solid conducting sphere and a hollow conducting spherical shell behave exactly similar in the case of electrostatic problems. Then at an outside point, intensity of a shell or a solid body is 1 by 4 pi epsilon 0 into Q by small r square. On the surface, it is 1 by 4 pi epsilon 0 into Q by capital R square. And inside, intensity is 0. Now we have to calculate capacitance of an isolated spherical shell or sphere. A capacity of a sphere, of a body or of a sphere by potential of a sphere, we mean potential at its surface. Absolute potential of a sphere of radius capital R is potential at its surface, and that is 1 by 4 pi epsilon 0 into Q by R. Now capacitance is defined as charge per unit rise of potential or charge per unit potential. That is C equals Q by V. V is, if the sphere is an isolated one or if there is only one sphere, then V is the absolute potential of the sphere, that is potential at its surface. So capacitance C equals Q by V equals Q by V. V is this much. So Q into 4 pi epsilon 0 R by Q. Q and Q would go. Then capacitance of an isolated sphere is C equals 4 pi epsilon 0 into R. Or capacitance of a sphere is proportional to its radius. You can use this result to compute capacitance of Earth, assuming it to be a perfect sphere. Earth is more or less a good conductor as a whole. Now, if radius of Earth is 6,400 kilometer or 6,400 into 1,000 meter, so that its capacitance is 4 pi into epsilon 0 is 10 raised to minus 9 by 36 pi into radius 6,400 into 1,000. You get it as 1 by 9 into 10 raised to minus 9 into this much. Or it is nearly equal to 7 into 10 raised to minus 4 farad. This is a very small number. So you can express it in microfarad. 1 micro means 10 raised to minus 6. So to change the answer to microfarad, just to divide the answer by 10 raised to minus 6, then you get capacitance of Earth is 700 microfarad. This divided by 10 raised to minus 6. So you get 7 into 10 raised to 2 or 700 microfarad. So farad is a very big unit. That is why the giant Earth has only this much capacitance when expressed in farad or microfarad. Thank you. Now our point is, what is the amount of work required to charge a spherical body? See this. This is the sphere. Initially, charge on the sphere is 0. You charge a sphere means you bring charge unit by unit, pieces of charge or units of charge or electrons one by one from infinity up to the sphere. So at the initially charge on the sphere is 0. So no work is required to bring the first unit of charge to the sphere because there is no repulsive force or attractive force to perform work. So potential, initially potential is 0. So you need not do any work. Now, when the charging has been completed, let Q be the charge on the sphere. That means if the potential, now when we introduced the first coulomb of charge, we have to do to bring a second unit of charge to the sphere because of the repulsion from the charge already present in the sphere. So we have to do increasing work as we proceed to supply charges to the sphere. At the final stage, let Q be the charge given to the sphere. And let V be the potential of the sphere. So the final amount of work required. Work is V is W by Q. So that work is V into Q. So final amount of work required is V into Q. V into Q. So V initially equals Wi equals 0. V final Wf equals V into Q. Therefore, the average work equals Wi plus Wf the whole divided by 2. That is V into Q 0 plus V into Q by 2, or that is QV by 2. But we know that Q equals C into V, or C equals Q by V, therefore Q equals C into V. So you can replace this Q as CV. Then the answer is work done is half V into CV, or half CV square. Half CV square. Or you can replace this V as Q by Z. Then work done, average work is half into Q by Z into Q, or Q square by 2C. Q square by 2C. There are two forms for the average work done. One is half CV square, or the other is Q square by 2Z. This work will be stored in the sphere in the form of electrostatic potential energy. So electrostatic energy of a sphere, charged sphere, is either half CV square or half q square by z. This is the expression.